Hi folks, this is 380 number 15a. So here they're giving us this function. They want to know what are the conditions on k so that f actually has critical points. Okay, so we're going to have to figure out what k can equal in order for the derivative to be equal to 0. Okay, so let's start by finding the first derivative. Okay, see what that gives us here. So we've got derivative of the numerator is 2. Multiply that by the denominator, so I'm just applying the quotient rule. Okay, minus 2x plus 4, the numerator function, times the derivative of the denominator, which is just 2x. Okay, and here we've got x squared minus k squared, the square of the denominator function. Okay, so let's simplify here. So we've got 2x squared minus 2k squared. And then here we've got minus, looks like 4x squared, and then here minus 8x. Okay. So let's keep simplifying here. So we've got 2x squared, and here, oh, sorry, we've got negative 2x squared. Okay, then we have minus 8x, and then here minus 2k squared. So sorry, 2x squared there. So I see that in the numerator, I'm just left with a quadratic. Okay, now I know the numerator needs to be equal to 0 in order for this fraction to be equal to 0. So let me start by factoring out a negative 2 here. So I'm left with x squared plus 4x plus k squared. Okay, so this is not factorable necessarily, especially since we don't know what k squared is. Okay, so what we'll have to do is use the quadratic formula. Okay, so we know x is going to have to be negative b, so negative 4 plus or minus b squared, which is 16, minus 4 times 1 times c, which is k squared, all over 2. Okay, but now let's think about what they're actually asking us for. They just want to know what the k value needs to be in order for there to be critical points. Okay, so the only thing we care about is that there actually are critical points. So in order for there to be critical points, essentially we need the input to this square root to be greater than or equal to 0. Because obviously if this expression is less than 0, negative in the square root, there's no solutions to that quadratic. So in order to have solutions to that quadratic, this discriminant here needs to be greater than or equal to 0. Okay, so this comes down to solving 16 minus 4k squared greater than or equal to 0. Okay, so again, the only thing we're interested in is that there are critical points. In other words, that there are points where the first derivative is equal to 0. Okay, so the way I can solve this is I can think of this, I would say the easiest way to solve this is think of this as a quadratic. Okay, so I have a quadratic inequality, so let me find the zeros here. So 16 minus 4k squared equal to 0 when k squared is equal to, what do we have? 16 over 4, so equal to 4, so k equal to plus or minus 2 when I take the square root. Okay, and if I were to sketch the graph here, I've got negative 2, and I've got 2, and this here is a quadratic with a negative leading coefficient, so it will look something like this. Okay, so where is this expression greater than or equal to 0? Between negative 2 and 2. Okay, so there are critical points if k, okay, is in the interval negative 2 to 2. Okay, so as long as k is between negative 2 and positive 2, this quadratic will have zeros, which will make the first derivative equal to 0. Okay, and that's it for this problem here. So I'll just pan out so that you can see the full solution. Okay, so start here, find the first derivative, okay, and determine when the solutions to those to that quadratic has real solutions.